yourselves, guys. There's a lot of interference. Okay, so we're trying to find the domain of this function here. Remember, the domain is the set of all the values of x for which this function is defined, right? So for this particular function, I was asking you guys, what do you think we should pose as a condition, right, for all the values of x when you have a function like this, right? So what values of x should we eliminate? That's what I was asking you guys. So anyone? Hello?
Eliminate all the values smaller than 2.
Right. All the values smaller than 2. Why? Why only smaller than 2? If you don't mind answering that for everyone else.
Because the lien of a 0 or a negative value is undefined.
Exactly, right? So we have to eliminate all the values that would make anything that is under the ln sign negative, right? So now, keeping that in mind, what we should do now is we take, so let me write it down here. We eliminate all the values such that x is less than or equal, right, to 0, because remember, it can't be equal to 0 here, right? You can't have the ln of 0, so you have to eliminate all the values of x that would make that 0 as well. And this just means, right, if you take 2 to the right hand side of this inequality, you have x should be then less than or equal to 2. Okay, so that's the domain. Now, no, well, sorry, that's not the domain, that's the set of values that we eliminate, okay? So if we were to draw our number line, just like we've done before, let's draw our number line. Our number line goes from, remember, negative infinity to positive infinity. Okay, that's where our number line goes to. And we said that we're eliminating anything that is less than or equal to 2. So if this is our 2 on our number line, we are eliminating 2 and anything that is in this interval here. Okay, so anything that goes there. And we are only considering really anything that is greater, strictly greater than 2. So our domain now should be 2, from 2 to positive infinity, and 2 excluded, right? So now look at through the options that are given here. You eliminate anything that tells you the domain is not what we just found here. So you eliminate A, it's not A, right? It's definitely not C. It could be B, right? It could be D. It's not E, and it's not F. Okay, so this is a way for you guys to sort of eliminate your options and reduce them quickly already, right? So now we have 2 options left. And the only difference between these 2 options is the range. So you have to find the range now. Okay, so you guys know what the domain of a function is. Now the range of a function is the set of all the values, right? All the values all the values that for which okay, so the set of all the values, please mute yourselves, guys. So the set of all the values, right, that this f of x could have, right? So when you plug in x, the range is the set of all the values f of x would have. So all the values that this could have, 1 plus ln of x minus 2. Now, based on what we have here, so if you plug, since this is our domain, right? So if you take any value in our domain, let's take 3, for example. If you take 3, because 3 belongs to our domain, right? Take 3, you plug it in there, you have 1 plus ln of 3 minus 2, which is ln of 1, which is, and ln of 1 is just 0, so which is 1, right? And then if you plug in, again, anything greater than greater than 3 again. If you take 4, for example, right? You have ln of 4 minus 2, which is ln of 2, right? And ln of 2 is positive, right? So as I'm sure you guys are aware, as you go towards very high values, right? The ln function is positive as you go towards very high values of x. So as you go along this number line here to higher and higher values, and you plug it into the ln of x minus 2 here, you will get very high values, right? You get positive values, meaning, right? So the lowest possible value, because remember, we can't plug in 2. So the lowest possible value that this could have is can be anything from negative infinity to positive infinity. Why? Because remember, since you're looking at R here, this is the set of numbers R, right? So if you take 2 points, because remember we're excluding 2, so if you take 2.005, for example, okay, that is not equal to 2. So you can plug it into this. But now when you plug it into that, you have ln of 2.005 minus 2, which gives you ln of 0.005, right? And well, you know that when you get to smaller and smaller values, the ln gets to closer and closer to minus infinity, right? So the set of values that this could have is anything from negative infinity to positive infinity, right? So our correct answer now, because we have 2 options left, our correct answer has to be D. Because B is telling us you can look at this both ways. So you can try to figure out what is the range, but you can also try to eliminate what is not the range, and then immediately you know what is the range. I'm not sure if you guys understand. Do you guys understand what I mean? Guys, I'm talking to you, just anyone. Do you understand what I mean by eliminating what is not the range, then immediately you know what is actually the range, because you only have 2 options left. So as soon as you eliminate one of them, then the answer is the other one. Do you guys understand that?
Yes, yes, you understand.
Yes.
You understand, right? So you can go about doing that way as well. So let's try to do that, okay? Let's say we don't know if the answer is B or D, right? So let's consider B for first. B is telling us that the domain is that, which we've agreed that's the domain. But now it's telling us that the range is any value from 0 included, right? to positive positive infinity, right? So what that tells you is 1 plus ln of x minus 2 cannot be, for example, minus 1. All of this, so this whole thing here, whatever value of x you find, it cannot be equal, for example, to minus 1. Okay? So that's what that range is telling you. But okay, let's do this then. Let's figure out. Let's say that, for example, we have 1 plus ln, because remember, guys, you were going by elimination now. Let's say we have 1 plus ln of x minus 2 is equal to minus 1. Right? And let's try to solve for x, okay? So if you take the 1 to the other side, you have minus 2. So now you have ln of x minus 2 is equal to minus 2, right? And when you have this, you introduce e, right? The exponent e. And that tells you from your identities of logarithmic functions, x minus 2 now has to be equal to e to the minus 2. And then you have then that x has to be equal to e to the minus 2 plus 2. Okay. Right. Do you guys understand this solution here, the way we solved this? Guys, I see a hand raised. Just unmute yourself and ask a question.
Sorry, can you go through that again?
Right. Okay. So what I said was, before we figure out that D is the answer, let's say that we've already eliminated A, we've eliminated C, we've eliminated E, and we've eliminated F. Now we're left with B and D, right? Now, what we're trying to do is we have to eliminate one of them, and immediately as soon as you eliminate one of them, you know that the other one is the answer, right? Do you understand until there?
Yes.
Now, what we chose to first see if we can eliminate is B. Let's choose option B and see if we can eliminate it. The domain, if you look at option B and option D, the domains are the same, right? So the only difference is the range. So let's consider the range. What I said was, B is telling us that the range has to be from 0 included to positive infinity, right? So the range, meaning the value of this whole function here, 1 plus ln of x minus 2, cannot be equal to a value like minus 1, because minus 1 is not in the range here, okay? Do you understand that?
Point alone.
Sorry? You understand?
Yeah, I understand.
So you understand that, okay. So, just give me a minute. There's some people who are having trouble joining, and you just need to reply. Okay. So, since the domain is telling us that it has to be anything from 0 to positive infinity, it means that this whole function f of x, right, cannot be equal to, for example, to minus 1, because minus 1 is not part of the domain. right? So what we're trying to figure out here now is, let's say that this function is equal to -1, and we try to solve for x. If we solve for x, right, and we find that the value of x is part of the domain, then you immediately know that option B is wrong, because you've proven that f of x, if you find a value that you've proven that basically there is a value of x in the domain that you can plug in into f of x to find that f of x is equal to -1. Do you understand?
Yes, I do.
You understand that? Any other questions, guys?
Is there a way to find the range by, you know how when you swap your x and your y?
Okay, yes, we could try that. Okay, okay, you swap your x and your y. So basically f of x is y here and x is in there, and then you just put y in there and x outside here, right? That's what you mean.
Yeah.
And then what do you do from there?
I don't know.
Okay, so that's the thing. So
Is it more complicated?
it's a bit more complicated, I think, because you have to go about when you do that, you basically now you're trying to express y in terms of x, right? So it messes up, but it's a bit more complicated. That's what I'll say. Than trying to, because remember, you're trying to like find the fastest way to solve this problem in a very big like exam or test situation where you have like 10 or something like 8 questions. So you're trying to find the most effective and fastest way to get to the answer while you don't lose too much time. So if you try it that way, I think you would find that you spending way too much time on trying to get to the answer when you could just eliminate one of the options, right? And immediately as soon as you eliminate one of them, you know that the other one is the answer. Okay. So going back to this, right? We are trying to prove that if you take a value like -1, which is not in the range that is given here, and you solve for x, you will find that x is in the domain. Because remember, for this function, for B to be the right answer to our question, any value of x that is in the domain must have a value in the range as well. Right? So that's how it works. Any value of x that you find in this domain here must have a value in the range. Okay? So if you find a value and vice versa, same. So any value, that's the functions. You guys know the definitions. 1:1, right? So one value of x in the domain is equivalent to one value of f of x in the range. And similarly, one value of f of x in the range must be equal to one value in the domain, because the function is 1:1. Right? Now, in our case here, we've found, so basically we've equaled this function f of x to -1, just to prove that -1 is not part of the domain of the range, as you can see, because the range goes from 0 to positive infinity, and -1 is not in that range. So if you take a value like -1, which is not in the range, and you try to solve for x now, which is what we did here, and you find the value of x, which is the one that we found here, which is 2 plus e to the -2. Now, this value that we found here, the value of x, is it greater than or smaller than 2? I'm asking you guys.
Greater than 2.
Sorry?
It's greater than 2.
It's greater than 2, okay? So if it's greater than 2, then immediately you know it's part of the domain, because remember our domain, which is the set of all the values that x can be, has to be values that are greater than 2, strictly greater than 2. So if you take 2 plus e to the minus 2, that is greater than 2. So you found a value of x in the domain that does not have a corresponding value in the range, meaning B cannot be the answer. Because remember, for B to be the answer, any value that you take in the domain should have a corresponding value in the range, and vice versa, any value in the range should have a corresponding value in the domain. Right? So as soon as you've eliminated option B, then option D is your final answer for sure, right? Because you've eliminated all the other ones. Any questions? I saw a hand raised.
Sorry, I wanted to know where can you get the worksheets?
Sorry?
I wanted to know where can you get the worksheet you're doing now?
This worksheet is on the ASAP page on Learn, right?
I can't seem to access the page on
Right.
the.
Okay. So what I will do now, okay, let me try to do it. I'll do it just after this meeting, right? So we don't get interrupted. I will send the link on the WhatsApp groups for you guys to self-enroll into the ASAP module on Learn. So basically what you will do is you press on that link, and then it will take you to Learn 2023. And then as soon as you logged in, right, all you have to do is just scroll all the way down, right? And then you'll see where it says enroll me. When you press that, immediately it enrolls you to the ASAP module, and now you can have access to all the modules for which you guys are doing SIs, and the worksheets, all the worksheets will be there. I see a hand raised. Hello? Okay. I guess I'll move on until you stop me. Right. So moving on to question 6. Here, again, we're looking at absolute values, right? Absolute values, and wait, let me just copy this. And what I was saying is, when you have absolute values and you have to define them in piecewise form, right? You have first to explore all the possible values of the absolute value, right? So, sorry, all the possible signs that whatever is under the absolute value sign can have, right? And for those who were there yesterday, we spoke about this in question 3. It was applicable in question 3, sub question A, right? And it will also be applicable to, oh no, okay, so that's the only one. But if you understand what we do here just now, you'll be able to solve easily question 3A, right? So here we have x plus 1, right? And basically what we have to do is study the sign of this, right? So let's say we have a number line, right? Which goes from, again, positive infinity, sorry, negative infinity to positive infinity. And what value of x makes this x plus 1 0? I'm asking you guys to see if you're following. Hello? What value of x makes x plus 1 0?
-1.
Minus 1. Right.
-1.
Thank you. So -1. Right? So if you take any value of x that is less than -1, meaning any value of x that is here, what happens to x plus 1? Is x plus 1 positive or negative? Negative, right? So let's put the negative sign. So all the values of x that you take that are in this interval from -infinity to 1 to -1, and you plug them into there, x plus 1, you have a negative value, right? What happens to the values of x that you take in this interval here? Guys? Positive. It makes this positive. Okay. Right. So now we've already started. We started the sign of x plus 1, and basically what piecewise means is you just have to define the function in terms of the possible signs that it can have. So now remember that when you take the absolute value of a number, whatever the sign of that number is, if the number is positive or negative, when you take its absolute value, it has to be positive, right? So now what happens if we are dealing with values of x that are in the interval from -infinity to -1? What happens, as we said, is it makes x plus 1 negative, right? And when you have x plus 1 negative, the absolute value will make that positive. And for x plus 1 to be positive, right, in this interval here, right, from -infinity to -1, you have to put the negative sign in front of it. Right? So guys, I'm sure you guys have seen piecewise functions with Dr. Mshlongo. So do you understand that? So that is if, right? If x is less than or equal, let's say, to -1. Do you guys understand that?
Yes.
You understand that? Okay. So now, when you take values that are greater than -1, so any values that is in here in this interval here, what happens is then it makes x plus 1 positive, right? Which is what we just found, right? It makes x plus 1 positive. And the absolute value of a positive number is just a positive number, right? So when you take a value of x that belongs to this interval, it just makes the function x plus 1 positive, so you don't have to put the negative sign in front of it. So it just stays like x plus 1, right? So when you take the absolute value, right? Again, f x now is greater than -1. Right. So now we've defined our whole function here, piecewise. Oh, sorry, not the whole function, but we've defined x plus 1 piecewise. So what I'll do is I'll copy that down here and paste it there. And then we'll try to do the same now for, okay, sorry. It's messing up with this. Just push it all the way down there and then, right. Okay, so now let's repeat the same process for x minus 2. So when you have x minus 2.
Sorry, sir.
Yeah?
I'm failing to comprehend. You said x plus 1 here, like where you put a negative sign.
Mhm.
I'm supposed to be x greater or equal to 1. Like underneath, you said x plus 1 is
Mhm.
is
Yeah,
greater than
right here.
negative 1. Yeah, it's supposed to be x is greater or equal to 1, and upward is supposed to be x is less than 1.
Okay.
Yeah.
No, it's fine.
Yes, that's true.
It works out to be the same when you see, but it's fine. Let's just do
Okay.
that way.
Oh, wait, if you put it this way, when you are plotting your number line, in terms of the x is in between, does it work for like what you've done here?
Okay, well, let's try it the way you said, and then let's plot it. Right?
Okay.
Okay, let's try it that way and see where it leads. Okay, let's do the same thing. Let me just erase here because okay. So in our case here now, we have x minus 2. So what happens? What is the significant number for x minus 2? So what makes x minus 2 0?
-2.
0, not negative 2. It's 2, guys.
Positive 2.
2, right? So what happens to x minus 2 in terms of sign? Is it positive or negative when you take a value of x that is less than 2? What happens?
Negative.
Becomes negative.
Becomes negative, right? So negative. Yeah. What happens when you take a value that is greater than 2? Positive. Right? Positive, positive, positive. So when you take a value that is less than 2, it makes x minus 2 negative, meaning you have to put the negative sign in front of it, right? When you take the absolute value, because remember, whatever you're taking, whenever you taking as when you take the absolute value of a number, it has to be positive in the end, right? And how do you make x minus 2 positive when x is less than 2? You just put the negative sign in front of it. And then whatever the negative number gives you there, it just becomes negative over negative, it becomes positive, right? And because we just found that it's positive, x minus 2 is positive for any value that is of x that is greater than or equal to 2, it means that it will just be equal to the same. You don't have to put the negative sign now again to make it positive because it's already positive. Right? 2, now we have less than 2. Now we have our all our signs for our functions. So now what we have to do is we have to draw a very big table, which I'm sure you guys are aware of, where you have right. So we have our x plus 1 in the first one, our x minus 2 there, and we have our first significant number there, and our second significant number. And the first significant number we had was -1, so -1 and 2. And this, of course, is negative infinity here to positive infinity. And our first interval is x plus 1, right? So that's the first absolute value that we have. And then we have x minus 2. And remember, we said that x plus 1 is 0, is equal to 0 at -1. So you put a 0 there. And we said that x minus 2 is equal to 0 at 2. So we put a 0 there, right? Where the two intersect. And then we said that for all the values that are less than -1, x plus 1 is negative. So you have equal to minus x plus 1, right? Minus x plus 1. And then we said for all the values greater than or equal to -1, x plus 1, the absolute value of x plus 1 is just equal to x plus 1, right? So that applies for this, right? So this part here and this part as well, x plus 1, right? So for all the values, and for the second one, x minus 2, we said that for all the values of x that are less than 2, it's equal to minus x minus 2, right? So less than 2, minus x minus 2, minus x minus 2. And for all the values that are greater than or equal to 2, we have the absolute value of x minus 1 just equal to x minus 2, sorry. And because we're adding the 2, right, it's plus. It's absolute value of x plus 1 plus absolute value of x plus 2. Now we have that x plus the absolute value of x plus 1 plus the absolute value of x minus 2 is equal to what? Let's look at the intervals. For the first one, you're just doing minus x plus 1 plus minus x minus 2, right? And this just gives you minus x, so minus 2x. And then minus 1 plus 2, which is just plus 1. And then here we have x minus x, which is 0, and 1 minus minus 2, which is plus, so 1 plus 2, which is 3. And then x, that's 2x. 1 minus 2, that's minus 1. So now we have the value, right? The values, the piecewise values of the function f of x, right? For all three of these intervals, right? So that's why I like to do it this way, because it's sort of clean. You can see what's going on. So this here is our x of f of x, right? So now if we had to plot this, which is what I'll do just now, because the question, remember the question is asking us to plot the piecewise, plot this function in piecewise form, right? Oh no, first express it in piecewise form, which is just what we did here, and then plot sketches graph, right? So again, this will be like a rough sketch. It's not exact, but it sort of gets you to the point. Okay. Right. So let's plot this. We have our x-axis. Oh, sorry, our y-axis there. And let's say our x-axis there. Again, this is rough, so it's not to scale, but it just so you can understand. Okay, so we said for all the, we have two significant numbers here, -1 and 2. So let's put them. We have, let's say we have -1 here. This distance 1, 2, and then 2 here, and then remember this is the origin 0. And we said that the entire f of x function is equal to minus 2x plus 1 when it's going from negative infinity to up until it gets to -1. So if you take, now you'd have to sketch -2 plus 1, right? So let's say we put x is equal to 0. You have, for x is equal to 0, you have y is equal to 1. So 1 somewhere here. And then we have, if let's say we put a value of less than -1, let's say -2. If x is equal to -2, right? Let's just put -2 here. If x is equal to -2, what I'm doing here is I'm trying to sketch this. -2, you have -2 times -2, which is 4. 4 plus 1, 5. So if this is 1, 5, let's say it's somewhere 2, 3, 4. Let's say 5 is somewhere here, right? So you have that for x is equal to -2, so they meet somewhere around here. And then we also prove that it meets there. So the function should go something like this, all the way up until it hits -1, because remember, -1 is another point of importance. So the function should go like this, right? And then when it hits -1, between -1 and 2, it's equal to 3, right? So where is 3? We said if this is 1, 2, 3, 3 is somewhere here, right? So it's equal to 3, meaning it's just a horizontal value all the way up until it reaches 2, right? We said between -1 and 2. -1 and 2. And then when it hits, when it hits 2, it's now equal to 2x minus 1, right? So let's plot 2x minus 1 again. If you plug in x 0, you have -1. So for 0, you have -1, which is somewhere, let's say here. And then if you plug in a value greater than 2, let's say 3, x is equal to 3, you have 2 times 3, 6, minus 1, 5. So for x equal to 3, which let's say is somewhere here, you have 5. So y is equal to 5. So if you have to link the two, you have somewhere here, and you should connect it to this one. So, but you can't cross the two, so it has to go like this, right? And that is how you would sketch a piecewise function. So it looks almost like a vase or something. Not a vase, but like the bottom of a plate, right? It's like a V, but a V that is flat at the bottom, right? Do you guys understand this? Any questions? Obviously, like I said, this is not to scale, right? So, and there might be some issues with it's not very tidy, right? So when you do it in a test or in an exam, you would have to do it clean with like rulers and pencils and stuff. But since we're just practicing in here, I'll just show you roughly how to do it and what it should look like. And then when you guys do it neatly, you will see that you should have a shape that is more or less the same. So, any questions? Hello? Guys, can you hear me?
So what about number 4?
Sorry?
What about number 4?
Number 4. This was number 5. Number 4, I was asking you guys and you told me that you didn't do inverse functions, which is weird because I'm sure you must have done it when you were doing.
We did inverse
Okay.
functions.
Sorry?
We did inverse functions, but
You did it. Okay.
our lecturer gave us no examples.
No examples. Right. So
Yeah,
for inverse functions.
It was a few examples. For example, a straight line only.
Okay,
Yeah, but
no,
not
so
inverse.
this might look scary for you guys, but it's not that scary. Okay, so just bear with me here. You have a function f of x is equal to x cubed over x plus 1, right? And they're asking you to find x if the inverse of f at x is equal to 2. Right. So the way inverse functions work is you have, I'll just have to draw it for you guys. So you have the domain of a function, right? F of x. And you have the range, right? So let's call the range R. And for a function that is 1:1, which I'm sure you guys remember, you have, if you take one value from the domain, you plug it into the function, you should get exactly one value in the range. And that's what we did here. And this goes both ways, right? Reciprocally. So one value of of x in the domain gives you one value of f of x, and one value of f of x is just equivalent to one value of x in the domain. And the way inverse functions work is for a normal function, you have the domain and then you have the range. For an inverse function, the range becomes the domain. Right? So I'm not sure if you guys understand what I mean. So for an inverse function of f of x, you just take whatever the range is. Please mute yourselves, guys. If you're not asking a question. So for the inverse function, you just take the range and it becomes the domain, and then the domain, the old domain becomes the range. And why is this important for our case? Because here we're we're asked to find a function, no, x, a value of x, such that when you plug f inverse of x, it gives you 2. Now remember, when you're looking at f inverse, now that's the inverse function, right? So now the values of x must be coming from what was before, what was the original range. So you're looking basically for, when you're looking at the inverse function, for a value. Wait, just give me a minute so I can find a better way to explain this so you guys understand. Okay, so maybe when I explain it this way, it might not be clear. So let's write it down. Maybe that will be more clear. When you have f inverse of x is equal to 2, and you plug this, right, into the original function. So let's say you're looking now for f of 2 is equal to what? It's basically just equal to f of f inverse of x. Do you guys understand this up to this point?
Yeah, we understand. The inverse
Okay.
becomes a y.
Right,
Or you
exactly.
swap them.
And then x now, because remember, the f of f inverse of x is just equal to x. Okay, so now you have, sorry, let me erase this. Now you have f of 2 is equal to x, because f of f inverse of x is just equal to x. That's one of the rules of inverse functions, right? So basically all you have to do is plug 2 into f of x to find x. Does that make sense, guys?
No.
Okay, let's get back to it. Right. So when you have f inverse of x, so basically it's asking you, right? They're asking you the value of x for which the inverse, right, is equal to 2. Right? So the value of x such that when you plug that x into the inverse function, it's equal to 2. But now remember that what we said was, for inverse functions, the range of the original function becomes the domain of the inverse. Okay? So
Sorry, sir. So
yes.
that doesn't apply only on trig functions only.
Sorry?
That doesn't apply only on trig functions only. It applies
Trig
here too.
functions. No, yeah, I think it applies to all 1:1 function, as long as the function is 1:1. So that's how it works, right?
Okay.
So basically, if I could explain it any better, this f of x, so this x in the f inverse is coming from what? It's coming from what is the range here of the original function. So this is coming from the range of the original function. And the 2 is coming from the domain. Now, I'm not sure if that makes any more sense, but basically, like I said, so the range becomes the domain and the domain becomes the range, right? So trying to explain it this way might seem a bit confusing, but maybe I thought when I write it down like this, it makes a little bit more sense, because here you have the f inverse of f of x is equal to 2, right? And then you just put f of x, f of 2. You just look for f of 2 now. F of 2 is just equivalent to now f of f inverse of x, because we've already said that these two are equal, right? From this. So from this, you get f of 2 is equal to f inverse, f of f inverse of x. And the f of f inverse of x is just equal to that x. Okay? Right? Same as in for trigonometric functions, which you guys are aware of. Same applies for trigonometric functions. Wait. So now you have now what to find the value of x. What you have to do is you take f of 2. So you plug 2 into the original function f of x, and immediately you found the value of x. So whatever that value gives you, when you plug 2 into this, you should get, that's the value of x that you're looking for, that they're asking you to find. Okay. So yeah, just take your time, try to go back to this. Okay. You can even take maybe a screenshot of this, but I'll be, like I said, I'm recording this, so you don't have to. You can go back to it and try to, and go back to your notes as well, and try to understand it better, right? Maybe it will make more sense when you actually like practicing. So all you have to do now to find x, like I said, is just plug into this, and you'll find the value of x. Now going to question, oh, okay. Going to this, the limits. So for these limits questions, we've tackled a few yesterday. Oh, okay. We tackled a few yesterday. Let me just do this. So today, we'll just tackle the rest of these. And what I was saying yesterday, for those who are there, when you're looking at the limits of as x tends to negative infinity of some function divided by some other function, what you do is, because x is tending to infinity, you take the highest term, you take the term with the highest order in x in the numerator, and then you divide it by the term with the highest order in x in the denominator. So you might ask yourself, what does that mean? Well, let's look at the numerator. In the numerator, you have 5x squared plus 3x, right? Now I'm asking you guys, what's the highest, what's the degree of this polynomial? You guys have done degrees and of polynomial. So what's the degree of that polynomial? Sorry? Yeah, so it's positive 2, so it's 2. That's the degree. So when it's 2, because 2 is the highest exponent that x has here, right? So that's basically the degree of the polynomial. So you take that term and you could basically ignore the other one, because again, when we're looking at very high or very low values, very small values like minus infinity, considering the highest exponent is enough, because you're just taking a very high value and you, sorry, a very, in our case, a very low value, and then you square it. So it becomes an even lower value, right? So when you're working, what I was telling the guys yesterday is when you work with very high values tending to infinity, either positive or negative, doesn't matter, high or low values, you should take, and you're doing the limits, right? You're working with the limits here. You can consider the highest degree and ignore the other lower degrees, right? Which is what you guys, I'm sure, have done with Dr. Mshlongo in your exercises. So in the denominator now, what's the highest degree for the function there? What's the order? Sorry?
+3.
It's 3, right? Because 3 is the highest exponent. So, meaning you can ignore the -4. And now you're looking for the limits as x tends to negative infinity of 5x squared over 7x cubed, right? And you can already simplify this by canceling the x in both the numerator and the denominator. So when you do that, you just cancel that, and what's left in the denominator is x to the 1, right, which is just x. Okay, I'm writing the 1 there so just so you can understand better the degrees and stuff. So now we have 5 divided by 7x to the 1, which is just 7x. And when you plug in minus infinity now, what you have is 5 divided by, just copy minus infinity, 5 divided by 7 multiplied by minus infinity, which is basically just 5 divided by minus infinity. 5 divided by a very, very low number, right? And what is that equal to? Or what does that tend to be equal to? This is from your limits, guys. You guys have done this. So what does that tend to be equal to? Guys, can you hear me?
Yes.
Yeah. So what
I
is that?
I think it's negative infinity.
No. Think about it. You're taking, right? If you want, right? Technically, it's not how it works. But
I think it's
if you
0.
want, right, that's true. But
It's
I'll try
0.
to explain why it's 0. If you want to simplify this, because you see minus infinity is a very low number, so you can take it as a very, very, very low negative number, right? So let's say you take something like 7 multiplied by minus any number like that, right? It's a very low negative number, right? This is, for example, this is just an example. So these are not equivalent, but it's just to illustrate what I mean. If you take a value like this, 5 divided by 7, right, multiplied by this. So when you multiply by 7 already, it becomes an even lower number, right? Right, rather a more negative number, right? So it becomes 5 divided by a very, very large number, but in the negatives, on the negative side. So it just becomes 0. It becomes closer and closer to 0, because if you take a small number and you divide it by a very, very, very high or very low in terms of the sign, then you get something close to 0. Okay, which is, or equivalent to 0, which is what you guys must have seen with Dr. Mshlongo. That's why it's equal to 0. Do you understand, guys?
Sorry, sir. Let's say we were dividing by positive infinity. What would be our answer?
It will still be 0, because now you're dividing by very high value. So let's say you're dividing 5 by 1,000,000, or 10 million or 100 million, right? That's a very positive value. That is, it's not infinity per se, but it's very high, right? So when you divide 5 by a number like that, it also gets closer and closer to 0. So it goes on both extremes, right? So when you divide a normal small number by a very high number, it gets closer to infinity. And also when you divide a small number by a very negatively high number, so it means a very high number on the negative side of the numbers, right? So minus something like minus 100 million or minus even a billion. You see, it's still a very high number, but on the negative side. So it still gets closer and closer to 0. I'm not sure if it makes sense.
Multiplied by BZK.
Do you understand?
Yes, yes, sir. Thank you.
Yes.
Right. So any other questions? Okay. I guess that's it. I'll have to stop it here because I see that we've gone way over time. Right. So for the other problems, right, it's basically the same thing that we just did here, right? So you do the same for this problem, that problem, and the other one. Okay, so the same applies. Don't be worried with the square roots and stuff. The same logic applies, right? Because when you're looking at very high values and you're taking the square root of them, it basically, especially when it becomes very, very, very high, it just stays, or it's still a very high value, right? Even if you take the square root of it. So it just stays high, big. So the square root doesn't really make a difference when you're dividing it, when you're dividing a small number with that value, right? So the same applies for the other questions here, the other 3 limits. So what I want you guys to do is to attempt it as well. There's 3, and then the final one here is just a bonus question that you guys can see and you can solve by using like trigonometric identities. You're basically asked to find the sine of pi over 12, and you'll break that down, right? The pi over 12 into 2 identity angles, like that are known, right? 60 and 45, for example, and then you try to solve for the sine. Okay, so I'm sure you guys can solve this as well. So attempt all of these questions, the remaining ones. And if you have any questions, I'll try to make myself available since you guys are doing a test next week, Friday. So whenever you have an issue based on this, okay? Don't send me tutorial questions or stuff like that, right? Tutorial questions are for your tutors. If you have any queries based on what we did here, right, today, that's what you should send to me. And for those who are not there yesterday, you can attempt the first 3 questions as well, and see if you do understand it, right? And if you don't, you can always send me a message with your attempts. Okay, so that's what I want to do. I don't want to say, oh, I don't want you to send me messages saying, well, sir,